Hello guys, welcome to Algebra. Imagine you throwing a ball into the air. It races, slows down, and stops in the mid-air, then falls back down. That motion is not random. It's mathematics. Today, we are going to see quadratic equations, not just solve them. As you know that all of quadratic equation has the general form of y equals ax squared plus bx plus c. But don't think of this as a symbols. Think of it as a machine. You put in a number x, and output is a number y. When we plot our outputs, we get a curve called parabola. Let's take a look at this example. If we have y equals x squared minus 2x plus 2, then we will plot all of x to y. We get 2. We substitute 1, we get 1, 2, 5, 8. Then we can plot this in a graph, y versus x. And this is the picture of graph y equals x squared minus 2x plus 2. And here's the key intuition. Squaring makes numbers grow faster the farther they are from 0. That's why the graph bends instead of staying straight. Here are some facts. Why parabolas are symmetric? Let's take a look at the simplest case. We have y equals x squared. If we put x equals 2 in the equation, we have y equals 2 squared, which is 4. If we have x equals minus 2, we get y equals minus 2 squared, which is 4 again. So, different inputs, same output. That means the graph must mirror across the vertical axis. So, the parabola has a perfect symmetry like this. Same output, different input. It because minus x squared is the same thing as x squared. Now, consider y equals ax squared. The number a controls two things. That if a is bigger than 0 and a is less than 0. If a is bigger than 0, we have the graph that opens upward, like a cup. If we have a is less than 0, we have the graph looks like this, like a cap. Why? Because positive numbers stay positive after squaring, but multiplying by a negative, it flips them. Every parabola has a special point, that is the vertex. It's the highest or lowest point depending on direction. This point represents maximum h or the minimum h depending on the parabola. Mathematically, we can have the equation to find the x vertex. X vertex is equal to minus b over 2a. But don't memorize it. We must understand. The vertex happens where the symmetry line sits, or the midpoint between the roots. For example, if we have two roots, then the midpoint between the roots are the vertex. Let's consider about this equation. Y equals x minus h all over squared plus k. Number h controls left or right, and k controls up or down. We take a look of this picture. We have this y equals x squared. This is the graph of y equals x squared. And then we can shift it like this. This is y equals x minus 2 squared plus 3. This is the same parabola as this, but it moves. Let's think physically. You are grabbing the curve and sliding it across the plane. And the vertex, this is become h or k in the coordinate. So this form is called vertex form. It tells you the graph instantly. So what is roots? The roots are where the graph touches the x-axis. Roots are solution to ax squared plus bx plus c, because the value of y we will find is 0, and what is the value of x? We call it x1 and x2. So we will solving equations is actually finding where the curve meets 0h, which is y equals 0, then x equals 1. So therefore, we have to find for all x, which ax squared plus bx plus c equals 0. Why quadratics model reality? Quadratics appear everywhere because many natural processes involve accumulated change. For example, area growth, energy relationship, optimization problems, and more important thing is motion with constant acceleration. Acceleration is change of growth rate or velocity. If we integrate acceleration, we get velocity. If we integrate velocity, we get position. And positions becomes quadratics after integrations many times. So, parabolas are the natural language of acceleration. A quadratic graph is determined by a, b, and c value. So, a control the shape and direction. If a is bigger than 0, we have a graph look like this. It's like a cup. If a is less than 0, we have a graph look like this. It's like a cap. If absolute value of a is small, we have wider parabolas look like this. If absolute value of a is large, we have narrower parabolas look like this. B controls horizontal placement. If b is less than 0, we have a graph that shifts to the right side. If b is bigger than 0, we have a graph that shifts to the left side. And C control the vertical starting point. which means that if we have the graph that its intercept in y-axis is some value, for example 3, then the c must be 3 in the equation. For example, y equals 3x squared minus 4x plus 3. And if we put x equals 0, we have y equals 3 times 0 minus 4 times 0 plus 3, which is y equals 3. If you understand the graph, you will understand the equation. Mathematics is not about memorizing formulas, it's about seeing patterns. And the parabola is one of the most beautiful patterns in all of math.